Welcome back, everyone. Today we're diving deep into something that's really changing the game in AI, the Model Context Protocol.
MCP.
MCP, right. You can think of it like a USB-C port, but for AI.
Yeah.
So it lets those large language models, those LLMs, actually connect to all sorts of data and tools.
It's all about integration. As AI gets more and more woven into what we do every day, the tricky part is making sure those AI apps can actually use all the information and specialized tools that are out there, but they're kind of scattered all over the place. That's where MCP comes in.
Makes sense. Now, I know you're all busy people, and you want to get to the heart of these ideas fast. So we've gathered some really in-depth sources on MCP. We're talking about everything, like how it's designed, how it's being used right now, and what the future holds.
Absolutely. What we're aiming for today is to break it all down, give you the core concepts. So by the end of this, you'll know exactly what MCP is, why it's such a big deal, and how it could potentially change the entire AI landscape.
Okay, perfect. So first things first, let's talk about the basic architecture. It's based on a client-server model, right? Like, you've got apps we use all the time, the Claude desktop app, even our coding environments. Those are the hosts, the clients.
Yeah.
And they connect to these MCP servers. So what exactly are these servers up to?
Think of them as the brains of the operation. They're the ones that provide access to two key things. You've got resources, which is basically the data and content the AI needs to work with. And then you've got tools, which are basically functions the AI can use to actually do things.
Got it. And then there are these prompts, which I guess are kind of like preset ways to talk to the LLMs. And the interesting thing is that these are controlled by the user, right?
Exactly. You're in the driver's seat when it comes to prompts. The server basically lays out these standardized request templates for the client app, and then it's up to the user to decide when and how to use them. It's all about having a consistent, clear way to ask questions or give instructions to the AI.
Makes sense. Then we have tools. And the key here is that they're model controlled. What does that mean exactly?
So with prompts, you're actively choosing to use them. Tools are different. They're designed for the AI model itself to decide when it needs a particular function to get something done. Of course, a lot of implementations have a human approval step built in before a tool actually runs, just to make sure everything's okay.
Right, so the AI can recognize that it needs something, like searching for information or running a piece of code, but you still have the final say. Now, going back to resources, where do they fit into all this?
Resources are basically all those different data sources that the server makes available to the LLMs. Could be anything from files on your computer to real-time data coming from an API. The key thing about resources is that they're application controlled. So the client app is the one that decides which resources are relevant to what the LLM's doing and when to make them available. Like with the Claude desktop app right now, you have to specifically choose which resources you want to give the AI as context.
Right, so it's not just throwing everything at the AI at once. Now, I see here we've got sampling. That sounds a bit different.
Yeah, sampling is a unique part of MCP. It lets the server actually request that the LLM generate some content or complete a thought. What happens is the server asks the client to do the sampling. The client can then take a look and maybe tweak that request a bit before sending it to the LLM. Then the LLM generates its output. The user gets to review it, and finally, the client sends the result back to the server. It's like a really interesting human-in-the-loop approach to content creation.
That sounds pretty powerful, like the server is being more proactive. Although I see here that this feature isn't active in the Claude desktop app just yet.
Not yet.
Okay. And finally, we have routes. That seems to be about setting a specific focus, right?
Yeah. Think of routes as like those "you are here" markers on a map. The URIs, those web addresses that the client suggests to the server as a focal point. It could be a certain folder on your computer or the main address of a web API. It's a way of telling the server, hey, this is where the important stuff is right now.
Okay, that's a great overview. Now, let's dig into the key features and components that make MCP work. We'll start with the protocol layer. What exactly is it responsible for?
The protocol layer is all about communication. It's the foundation that defines how messages are structured, how requests get paired with responses, and basically how the client and server talk to each other. It's like making sure everyone's speaking the same language.
Got it. And this communication follows a specific life cycle, right? You've got initialization, message exchange, and termination. There's even a diagram here, a mermaid diagram, showing how initialization works.
Yeah, so at the very beginning, you have the initialization phase. The client sends an initialized request to the server, which basically says, hey, here's the version of MCP I'm using, and here's what I can do. The server replies back with its own version and capabilities, and then the client sends an initialized notification to say it's ready to go. It's like a handshake before a business meeting.
Makes sense. What about when things go wrong? How does MCP handle errors?
Well, MCP has a set of standard error codes. So when something goes wrong, it's clear what happened. For example, there's a code for when a request is invalid, another for when the server doesn't recognize the method being requested, and so on. And when an error happens, the server sends back one of these codes along with a message that actually explains what went wrong in plain English.
So it's not just a generic error message. That's helpful. And the actual sending and receiving of these messages between the client and server, that's handled by transports, right? We have CDO, SSE, and the option for custom ones, too.
Right. CDO stands for Standard Input Output, and it's really common for local communication. Think of it like this. If you have a tool on your computer talking to a server on the same machine, they can just exchange data directly. It's probably efficient.
Okay.
And then you have SSE, which is server-sent events. That's designed for when the server needs to send a stream of data to the client over a regular HTTP connection. The client makes a request, and the server can just push updates as they happen. It's handy when there are network restrictions or when you just need simple updates from the server. And of course, MCP is flexible, so if CDO or SSE aren't the right fit, you can create your own custom transports.
So it can adapt to different situations. That's important. Now, let's get back to some of those core components we talked about earlier. Let's start with prompts. We know they're structured in a specific way, but how does a client actually find out what prompts a server offers?
Easy. Clients send a prompts list request to the server. The server then sends back a list of all its prompts, each with a name, maybe a description to explain what it does, and a definition of the arguments it needs.
Right, and we have some examples here like git commit and explain code. How would those actually be used?
Sure. Let's say you have the git commit prompt. It might have an argument called changes, where you describe the changes you made to your code. When a client app wants to use that prompt, it would fill in the changes argument with the details, and the server would use that information to format a message for the LLM to generate a good commit message. Same idea with explain code, where you'd have arguments for the code itself and the programming language. Really streamlines common development tasks.
Yeah, and I can see how those could easily be built into a user interface. Like imagine using slash commands in your code editor, kind of like what Zed does. What happens when the underlying data changes? How does MCP keep things up to date with resource updates?
So there are two main ways servers let clients know about changes to their resources. First, whenever the set of available resources changes, like if a new file is added or deleted, the server sends out a notifications resources list changed notification. Second, if a client wants to keep track of a specific resource, it can use the resources subscribe request. Then, whenever that resource's content changes, the server sends a notifications resource updated notification. The client can then fetch the latest content using resources read.
So it's like a proactive system, keeping everyone in the loop. Now, let's get back to sampling. We talked about the overall process, but what's actually in that request the server sends to the client?
So the server starts a sampling request with a sampling create message to the client. This message has a messages array, which is basically the conversation history up to that point, just like how you'd interact directly with an LLM. Each message in the array has a role, user, or assistant, and content, which can be plain text or even images encoded as base 64. The server can also give model preferences, hinting at which AI models might be best for the task based on things like cost, speed, or overall smarts. There are also optional fields for a system prompt, which sets the context from MCP, and parameters like temperature and max tokens to control the sampling itself. So even though the client's the one talking to the LLM, the server has a lot of control over how it happens.
So it's a collaborative effort. And what about tools? How does a client know what tools are available and how do they actually use them?
It's a lot like prompts. Clients send a tools list request, and the server sends back a list of its tools. Each tool has a name, a description, and what's really important is the input schema, defined using JSON schema. JSON schema is a standard way to describe the structure of JSON data. In this case, it defines what parameters the tool needs when you call it. To use a tool, the client sends a tool score request, saying which tool it wants and giving the arguments in JSON following that input schema.
So that JSON schema is like a guarantee that the client's giving the tool the right input. Now, we mentioned different categories of tools like system operations, API integrations, and data processing. Can you give us an example of each?
Sure. A system operations tool could let the LLM, with your permission, of course, do things like list files in a directory on your computer. An API integration tool could be like a wrapper around a service, like a weather API, so the LLM can get the latest weather for a location. And a data processing tool could let the LLM analyze data from a CSV file you provided. Shows you just how versatile these tools can be.
Very cool. What if a tool runs into a problem or doesn't finish successfully? How does MCP handle errors in that case?
Tools have their own way of reporting errors. When a tool finishes and gives its results, there's a flag called ISERROR. If it's true, that means something went wrong. And the results will include details about the error so the client, and maybe even the LLM, know what happened. That way, the LLM can try something else or let the user know there's a problem.
So the errors are communicated clearly. Now, all this communication follows a specific message format, right? It's based on JSON RPC 2.0.
That's right. MCP uses JSON RPC 2.0 for all its messages. It's a well-established standard that provides a clear structure for all the communication between clients and servers, requests, responses, notifications, everything. It's like using a standard envelope so everyone knows how to read the information inside.
Makes sense. Okay, we've covered a lot of the technical stuff. Now let's talk about who's actually using MCP out there. We have a section here on ecosystem and integrations, and it lists a ton of applications.
Yeah, it's really exciting to see how much momentum MCP has. The list shows a wide range of applications that are either already using MCP or are looking into it. We're seeing it in development tools like the Claude desktop app, Continue, Cursor, and Zed. These are all using MCP to give you smarter AI assistance right inside your coding environment. Then you have agent frameworks like Fast Agent and Daydreams agents that are building their core features on top of MCP. And even bigger platforms like GenKit and Apify MCP Tester are adopting it. And it doesn't stop there. You've got tools like Klein, Copilot MCP, SourceGraph Cody, Super Interface, Spine AI, OpenSUMI, LiverChat, Goose, Genescript, and RuCode, all finding different ways to take advantage of standardized AI connections. Think about those development environments. With MCP, you could be coding, and right there you can ask your AI assistant to search your project documentation or run some code analysis, all without leaving your editor.
So lots of different ways to use it. What are the main benefits for these apps that are choosing to adopt MCP?
There are quite a few, actually. First off, MCP lets applications easily integrate external knowledge and specialized functions by connecting to different MCP servers. This means users can bring their own data and tools into their AI interactions. Second, by using a common open protocol, all these apps become part of this growing ecosystem of interoperable AI tools. That gives users more flexibility and choice because they can mix and match different AI capabilities from different providers. Third, MCP is really flexible in how it integrates. Apps can choose the best transport mechanism and interaction patterns for their specific needs. And lastly, a lot of apps really value the strong support for local-first AI workflows. That means sensitive data and processing can stay securely on the user's own machine, which is great for privacy and security.
So it's like everyone's agreeing on a common language for AI to communicate. That's a big step. And for developers who are interested in adding MCP support to their apps or building new MCP servers, there are SDKs to make it easier, right?
Absolutely. MCP provides really good SDKs. Those are software development kits for both Python and TypeScript. These SDKs take care of a lot of the complicated low-level details of the protocol so developers can focus on the specific things they want to do with MCP. It's like having a set of pre-built tools to make development faster.
Okay, now let's look ahead. What's on the roadmap for MCP? Our outline mentions some key priorities for the first half of 2025. What's coming up?
So the top priority for the first half of 2025 is remote MCP support. This is huge because it means you'll be able to connect to MCP servers over the internet securely and reliably. A big focus here is on authentication and authorization, especially supporting OAuth 2.0, which is the industry standard for secure access delegation. Being able to access remote data and services securely will open up so many new possibilities for AI apps. For someone who uses cloud-based AI, this remote support could completely change how those services work with their local data or other remote tools.
So remote access is a game changer. What else is in the works?
Another big area is expanding agent support. They're working on making MCP better at supporting hierarchical agent systems. That's where you have multiple AI agents working together in a structured way to achieve complex goals. They're also looking at improving interactive workflows, making it easier for agents to ask users for permissions and send structured output back for review or action. And they're working on streaming results, which will let you get real-time updates from long-running agent operations. That will make those complex AI interactions feel much more responsive.
So MCP is evolving to handle more and more sophisticated AI scenarios. Beyond these core areas, what's the vision for the broader MCP ecosystem?
The roadmap also talks a lot about building a strong and collaborative broader ecosystem. They want to encourage community-led standards development to make sure MCP becomes a truly open standard that meets the needs of all kinds of AI developers and providers. They're also exploring the possibility of supporting additional modalities beyond just text, like audio and video. That would really open up the possibilities for all sorts of applications.
It's exciting to see what's coming. And it looks like there have been some recent updates to the SDKs as well.
Yeah, there have been some big advancements. The Kotlin SDK just hit version 0.4.0, which now supports multimodal data, has end-to-end testing within the Fast Agent framework, and seamlessly integrates with the Claude desktop app. The Java SDK, which is now officially maintained by the Spring AI team, is up to version 0.8.1, showing that it's becoming more mature and widely used in the Java world. And the Python SDK was updated to version 1.2.1 with some important improvements that let MCP servers give more context, tools, and prompts to client apps.
It's great to see this kind of active development. Now, for developers who are actually building with MCP, what are the important things to keep in mind for development and debugging? Are there any special tools or techniques?
Debugging is super important in any development work. For MCP, a really useful tool is the MCP inspector. It's a dedicated user interface for testing and debugging MCP servers. You can easily see the resources a server is offering, test its prompts and tools, and watch the notifications in real time.
Sounds very handy. What about more traditional debugging, like logging?
Logging is still crucial. MCP servers should have good logging to keep track of everything that's happening. Protocol events, messages, performance, errors, the whole 9 yards. And client apps should log their network traffic and messages too. A typical debugging process might involve writing the server code, integrating it with a client like the Claude desktop, and then carefully looking at the logs on both sides to find and fix any problems.
Makes sense. Are there any example servers available that developers can use to learn from or get started with?
Absolutely. The MCP project has a fantastic collection of example servers that are like reference implementations for all sorts of things. There are examples for accessing local data and file systems, like the ones for file system, Git, and Google Drive. Then there are integrations with popular development tools like GitHub and GitLab, web automation frameworks like Brave Search and Puppeteer, productivity apps like Slack, and even AI tools like EverArt. There are also official and community integrations for technologies like Axiom browser-based, Docker, Kubernetes, and Spotify. The MCP documentation shows you how to run these example servers using command line tools like npx for TypeScript servers and uvex or pip for Python ones. They even have a practical example of how to configure these servers in the Claude environment using a JSON file. It's a great way to learn by seeing real-world examples.
Yeah, seeing practical examples always helps. And for someone who's completely new to MCP and wants to build a client app, are there any quick start guides?
Definitely. The MCP documentation has really clear quick start guides for different programming languages and frameworks, including Python, Node.js, Java Spring, Kotlin, and C#. They take you through all the steps: setting up your environment, handling API keys securely, structuring your code, connecting to a server, sending queries, and actually running your app. They even have a tutorial on building a weather server that exposes its functionality through MCP tools. It's a great hands-on learning experience.
So there's a lot of support for developers of all levels. Now, the last big topic is something really interesting: building MCP with LLMs. Can we actually use a language model like Claude to help us create MCP components?
That's a fascinating idea. Because MCP gives us a standard way for LLMs to talk to the outside world, we can absolutely use an LLM like Claude to help design and build AI integrations with MCP. Imagine describing the functionality you want for an MCP server. Maybe it connects to a specific type of database, exposes certain data fields, and provides tools for querying that data. You could ask Claude to help you write the code for that server.
That's like using AI to build the infrastructure for AI. Pretty meta. What are some best practices if someone's using LLMs to build MCP components?
When you're using LLMs to build MCP servers or clients, it's really important to break down complex features into smaller, more manageable pieces. Test each part thoroughly as you go to make sure it's working correctly. Security is paramount, so make sure you validate inputs and carefully control access and permissions on your server. And of course, good documentation is essential so that you and others can understand how everything works.
So it's a collaboration between the human developer and the AI assistant. Well, we've covered a lot of ground today on the Model Context Protocol. For our listeners, what are the key takeaways you'd want them to remember?
In a nutshell, MCP is a major step forward because it gives us this standardized, flexible framework for AI applications to work with all sorts of data and tools. Its client-server design, with resources, tools, and prompts, gives you a powerful foundation for building custom AI workflows. And with so many applications adopting MCP and active development happening, it's got a really bright future as a unifying force in AI.
I hope you've had some real aha moments listening along. The flexibility and power that MCP gives to developers and ultimately to users like you is really amazing. It's like that USB-C port for AI, opening up a whole world of possibilities and streamlined interactions.
As you go about your day, think about the apps and services you use. How could MCP make those experiences better with AI? What new features or seamless integrations could be possible if AI had a standard way to connect to all these tools and data sources?
That's a great question to ponder. As the model context protocol keeps evolving and more people adopt it, it's going to be really interesting to see how it shapes the future of how we use and benefit from AI. Thanks for joining us for this deep dive. We'll see you next time.